This is the paper on user item collaborative filtering recommendations for Yelp users. This is a user item based recommendation system that uses the K nearest neighbors algorithm. It finds users with similar preferences in restaurants to predict a user's rating for a restaurant they have not visited. And this project is inspired by a technical report by Ji-Hoon Hwa for such a system, which decided to group restaurants by food categories to reduce the sparseness problem in KNN and analyze results. So the approach involves extracting this data set from JSON files and parsing it using pandas libraries and JSON libraries, and a lot of pre-processing, which includes removing garbage values and cleaning out the data and doing joins and merges like you would in SQL, but only in Python. Then two separate sets of data sets are fed in are converted into a two-dimensional sparse matrix of users in restaurants, one where data is clustered into manually into food groups such as American or Italian and so on. Then this data is prepared to be fed into the K-neighbors classifier method through encoding the data and making it more sparse. The model is tested for different values of K, and then I try to improve it, and the output is ratings for any. So the data set is publicly available on Kaggle. It's appropriate for user item collaborative filtering, as users are much more than items. And a lot of pre-processing is involved. Increasing information density is done by applying popularity thresholds, as discussed in Maheshwari's book. The implementation used a lot of Python's libraries, and for pre-processing, the paper mentioned had no mention of what value of K was used, what distance measure was used, how data was clustered, because it's a semantic thing. It's a subjective thing. Whether I would put pizza as a food group or pizza would come under Italian. It's a so that's where the project deviated. I ran it for different distance measures, the model, and I got the best results with Minkowski, which is what I went with. These are the X parameters used on the slide. I had to compress the two-dimensional matrix as it was very heavy, and 99% of it was sparse, which comes back to the same problem that there are less likely to be users that have visited the same set of restaurants. Food clusters were found based on reading a couple of research papers on the Yelp dataset. RMSE was the evaluation used by the other technical report. However, this evaluation found results of RMSE to be much lower in the first place by the baseline K nearest neighbors. With clustering, however, the funny thing was there was not much improvement. This again might be because of the difference in the size of data set between then and now, and the difference in the way the clusters were formed and different values of K and distance measures. Then I tried to improve results by adding different attributes to the model, such as the review count of businesses and the city and state in which they were, to see if the model would improve, and it did improve marginally. However, the most difference was found by normalizing the data, a technique covered by Sarwar's paper. On the same, it means adjusting the distance measure so that uh, just subtracting the average rating of each user from their individual ratings, which uh, normalizes or standardizes the data and removes the bias of each user. For example, I might be a very generous rater, but the other person might be very strict, so that bias is removed, which gives such good results. And hence, these results portray that grouping does not have a large impact on the performance of this model for the Yelp dataset, and normalization is very important.